a demo about YuniKorn Federation. So first, let's take a look at the architecture. In this architecture, we will have a host cluster, and we'll have two compute clusters. The compute clusters, each of the compute clusters will have YuniKorn deployed as a YuniKorn member, and the host cluster will deploy a YuniKorn head. The member service will reporting themselves to the YuniKorn head in order to set up a federated cluster. And the first thing we're going to do is to deploy the YuniKorn head service. Okay. Simply bring up the replica, and once the pod is running, I can take a look the UI here. So UI can be accessible from here. So right now we do not have any data, so because we don't have a member joined yet, so there's no nodes, there is no application, no queues, no nodes, nothing. The next thing I'm gonna do is to set up the members. So this is a window for another EKS cluster. This is another one. Both of them are compute clusters. So I'm going to bring up the YuniKorn member service on this cluster. Once the pod is running, we can take a look at the UI. Okay, now we have 4 nodes, and these 4 nodes are exact the nodes being reported back from this compute cluster. And then I do again with another member. So once the member gets started, we will see the member being registered to the server. Then we'll say a node. All right, we have a node. We have the queues. The queues we set up with 4 different queues, with each of them will have a certain resource capacity. But actually, the physical nodes are running in other clusters now, not in the host cluster, right? The next thing I'm gonna do is to submit a job. So I'm going to submit a job directly to the host cluster, and we're not running any of the pods inside of the host cluster. Instead, we'll be dispatching that job to a specific compute cluster. Then this will be a very simple example. So we can take a look at the member. Very simple Nginx application, 5 replicas, and I'm submitting that to. We're using a placement to submit that to the first compute cluster, and we're using the placement today, but eventually we can replace this with some of our own logic of job dispatching. Okay, so we create the first job. Once we create that, we can see the job being launched in the first compute cluster. In the sandbox namespace, everything is working as defined, as expected. Let's go back to the UI. So what user will say is, in the application now we have 2 applications, and we can track the details about this application we just submitted. There are 5 pods, and each of the pods will be having allocated to some nodes. But you will see, because this application is being submitted to the first compute cluster, all the nodes should be in the first cluster. And also look at the queues. In the queue where we have a root queue, this indicates that some of the resources being used. And we have submitted the job to the sandbox. We'll see some of the resources being used in the sandbox queue. And you can track the used capacity and the total configured capacity in the detail page. Also, you can track the allocations, the pods, in the nodes page as well, where we can see where the pods are running. So on this node, we run 4 pods, and there's another pod being allocated to another node. Yes, here. Okay. So as you can see, we submitted the job from the host cluster, and that job gets dispatched to the compute cluster. And from the central view, we still get tracking of the, we still have the track of the application. We still have the track of the resource utilization, and we can still enforce the, high-level resource code management. Then the next thing to do is I wanted to create another job. So very similar, I'm going to submit a second job to the second member, which is the second compute cluster. Let's see what happens. Once I click submit, there we have another 2 pods being launched in the second compute cluster. If we go back to the UI, we will see, okay, the queue has a little bit more resources being used. This is aggregated the resource usage from both 2 jobs. We're submitting them to the same queue. And in the application page, we'll be able to track the application, the status about the second application. We will see how the location looks like, and also all the information up to the nodes as well. Basically, in this UI, you can manage everything. As an administrator, you can just plan your capacity with our resource queues, submit applications to a certain queue in order to control how the resource will be used. But underneath, our load balancer and the provisioner will help to scale up more compute clusters if needed, or destroy some of the clusters to reduce the cost. So all those things are happening underneath. So that's basically what I want to demo. Thank you.